What's up, guys? This is my 4-week Vision Tech project demonstration. And for my project, I did a clock slash calendar slash temperature sensor for my car. And so today I'm going to show this thing off to you guys. So, welcome to my truck. 79 Ford. It's this little box right here. So I'm going to turn on the car. And it's coming on right now. Get a little loading message, and there we go. You can see it displaying the time, the date, and the temperature in Fahrenheit because I'm an American. And yeah, that's pretty much all it does, but surprisingly, it's a lot of work to get something to do that. What I used was an Arduino and some code that I got off the internet and changed and combined it with other code that I got off the internet. And then I put it all in this cardboard box that's custom. So now I'm going to show you all about the innards of this thing. Okay, so here is the project, and this is the innards. Got my Arduino Uno, a real-time clock module, and a LCD. This is actually from an old 90s Nokia phone, so that's pretty cool. It came on the circuit board, and I can just hook it up to my Arduino and program it to work, or download code and change it to my needs or whatever. And I don't want to leave this thing on all the time. I want it shut off from the battery so it doesn't drain my car battery. So the perfect solution was these deals, and they've got a little watch battery in there, so they record and always keep track of the time even when the rest of your project is turned off. So when you turn it back on, the Arduino can just send a signal out to the real-time clock, and it'll send back the time and date, and there you go.
Hi, my name is Aaron, and today I'm going to go over my stereo system that I created in a technology class called Vision Tech. So I started by taking apart an old stereo system that contained the top two speakers in my new stereo system, as well as the radio. My two 12-inch subwoofers are the brand Boss. They have a max peak of 800 watts, RMS power handling 400 watts, RMS root mean square, which means how the speaker handles the audio signal power. My two 6-inch speakers are from a very old stereo system, and I'm not exactly sure who made them. I learned that through hard work, dedication, and planning, you can make whatever you want. I wanted to make a stereo system, and that's exactly what I did. I think that the most successful moment is when you know you have completed something you have worked hard on.
Hey guys, this is Caleb, and for my project, what I did was, it's called a RetroPie. It's an operating system for the Raspberry Pi, which is basically this, and this is a whole computer in itself, and it's, you know, the size of a little bigger than my palm. But what this operating system does is you play old school games on emulators such as things for the NES, SNES, Sega Genesis, etc., old Game Boy games. And it's pretty fun. You just load ROMs onto it and it just pops them up there for you. And my goal here was learning a little bit about how to just, you know, write an operating system to this, because it's all in this little SD card back here. So, and for what I had to do, or whatever you really need hardware-wise, was obviously a Raspberry Pi, a mouse and a keyboard for the initial setup, and I went with an SNES controller, but it does have an option that you can install a driver for an Xbox 360 or a PS3 controller. I tried it, and I didn't have much luck with it. And obviously your SD card, and to start loading your games onto it, you do have to have an Ethernet connection to your router. But I went ahead and threw an SNES game on here last night or sometime before, which I'd put Super Mario World, because why not? So fire that up. And it goes into a little boot screen. Shows that has a controller plugged in along the bottom. And there we have it. Got a game going.
This time I worked on Terrence, and that is my name for this little robot thing here. He is comprised of some PVC, this piece of plastic you see here, and that front bumper. I pulled this off of an old remote control truck. But underneath, he's made up of 2 circuit boards, one from one old remote control car and another from another remote control car. He also has this big old battery pack on the back, and that's his horn. Right now he's running off of 18 volts roughly, each going out to it's all going out to each of the circuit boards. I have them wired up in series, so they're both running into right in there. So there he goes, off to the races. Yep, there he is. And that's what he does.
Okay, today I'm showing my Raspberry Rover project, and basically what it is a Wi-Fi controlled robot that you can connect to and can control it. Here is the motor drive. It converts the Raspberry Pi's digital signals into an analog signal, so it can convert it from digital to analog. And analog is just an electronic signal that these DC motors can pick up, a positive and negative side, and they're all hooked up. They hook into the bottom half of this, and each thing is categorized with A01, which is motor port 1, which converts it from this. This side is the all the sides green. That's the side. These are the IR lights that are part of it. They help the camera see when you go into darker places. So greens are negative and reds are positive, and there's supposed to be a 58 ohm resistor in between each little bit. IR lights, which you can see here with the IR lights, and then on top would be the servo would be connected up here along with a webcam, and then battery pack along with DC to DC converter for this motor driver, which takes 5 volts, and the Raspberry Pi can only take 3.3 volts. So